Welcome to MATHSOLOGIA. In this video, we discuss the problems related to Poisson probability distribution. So this is the first question we have to discuss. 2% of the fuses manufactured by a firm are found to be defective. Find the probability that the box containing 200 fuses contains no defective fuse, 3 or more defective fuses. First, let denote X here, number of defectives. Denote the number of defectives. Because the problem is concerned with the defective items, so we call X as number of defectives. Given, probability is given here, 2% of the fuses are defective. That is, P is equal to 2%. 2% can be written as 2 by 100. 2 by 100 is 0.02. This is probability. And given n equals to 200. So here n is equal to 200, which is quite very large, and p is 0.02, which is very small. Therefore, we use Poisson distribution. In the problem, they didn't mention which to be applied, binomial distribution or Poisson distribution. But by understanding the question, so we have to be very careful in deciding which distribution should be applied here. We apply Poisson distribution because here n is large. Because n is large and probability p is small. So that's a technique to decide which distribution to be applied. So we have p of x is equal to x given by m power x e power minus m by x factorial. This is the probability distribution function of Poisson. In this distribution, we need to find only one parameter, that is m. Here m is called mean, where m is equal to np. How did we get np here? In the last video, we have discussed the proof of mean. There we got mu is equal to m. But what is mu? Np. So m becomes np here. So m is equal to np. N is 200. P is 0.02. Multiply, we will get 4. 200 into 0.02 is 4. Next, we have to solve the probabilities one by one now. So what is the first question asked here? Find the probability that the box containing 200 fuses contains no defective fuse, 3 or more defective fuses. You have to find probability that the box does not have any defective fuse. No defective. No defective means we have to put the value in place of x 0. That is no defective. Probability of no defective. So before that, we have to substitute here m value. M is 4, 4 power x, e power minus m by x factorial. So this is the Poisson probability distribution after putting m is equal to 4. Just here to substitute x is equal to 0, 4 power 0, e power minus 4. So here also we should replace 4 because m is 4 here. Minus 4 by x factorial. X is representing 0. So 0 factorial. The answer will be 0.0183. See, e power minus 4 can be calculated from the calculator. Here you have an option in calculator like this, e power. Just type the number e power minus 4 here. We get answer 0.0183. Second question is probability of 3 or more defectives. 3 or more defective means we have to take here p of x greater than or equal to 3. Includes 3 and more than 3 means greater than or equal to 3 have to take. If you go in this direction, it will be very difficult to find probability. It is a lengthy job because we have n is equal to 200. N 200 means we have 0, 1, 2, 3, 4, etc. up to 200. This direction means starts from 3 and 200. Very difficult to find probability. We can convert this 1 minus p of x less than 3. So less than 3 means here before 3 we have 3 numbers 0, 1, 2. Just we have to find those probabilities. X is equal to 0, x is equal to 1 plus p of x is equal to 2. Substitute x is equal to 0 in the distribution function. 4 power 0 e power minus 4 by 0 factorial. Next 4 power 1 e power minus 4 by 1 factorial. 4 square e power minus 4 by 2 factorial. Calculate. The answer will be 0.7619. In 76% chances are there the box contains 3 or more defectives. Here it is very less, 1.8%. Right. The probability that the box contains 0 defectives is very small, 1.8%. So this is the question. If they give probability in terms of percentage, we should take 2 by 100 because 1% means 1 by 100. Out of 100, 2 are defectives. That is the meaning. So we'll go to the second question now. Next, a certain screw manufacturing machine produces on an average of 2 defective screws out of 100. Here also the problem is based on defective items only. Let us denote X as the number of defectives. Number of defectives. Here average of 2 defective screws out of 100. Okay, 2 defective out of 100 implies probability is what? 2 by 100, 0.02. So out of 100, 2 are defectives. So probability of getting a defective is what? 2 by 100. So 0.02. And n is given to be 500. Therefore, m can be calculated that 500 into 0.02. You will get here 10. If you multiply these two numbers, 10. And here we have to use Poisson distribution because n is very large, 500. Probability is small. For large n values, for small probability values, we will use Poisson distribution. It follows Poisson distribution. We have p of x is equal to x equals to m power x e power minus m by x factorial. Substitute m here, 10 power x e power minus 10 by x factorial. So formula is fit here for Poisson distribution. Now we have to find the probabilities asked in the problem. Find the probability that a box contains 3 defective, at least 1 defective, 15 defective screws. Exactly 15. Here exactly 3, at least 1 defective. So we have 3 questions here to be obtained. First question, 3 defective, right? Probability of 3 defective. Exactly 3 defective. Substitute x is equal to 3 in the above formula. We get the answer. 10 cube into e to the power minus 10 by 3 factorial. The answer will be 0.000757. Second, probability of at least one defective. At least one defective means P of x greater than or equal to 1. Includes 1 and greater than 1. This direction difficult, so we convert this into another form, alternate form, 1 minus p x less than 1. P x less than 1 means we have only one value before 1, that is 0. X is equal to 0 means here 10 power 0 e power minus 10 by 0 factorial. 1 minus 10 power 0 is 0 is 1, 0 factorial is 1, and left is e power minus 10. It is almost equal to 1 itself, because e power minus 10 means it is almost equal to 0. So therefore approximately 1. Third question, we have to find probability of 15 defectives. 15 defectives means we have to put exactly x is equal to 15. So 10 power 15 into e power minus 10 by 15 factorial. So this gives answer 0.0347. This is the answer. First two problems are similar, except the probability what they given in different form. Here 2 out of 100 are defective. Directly they mention 2% is defective. That's the only difference between these two questions. Next, third question. If the probability of a bad reaction from a certain injection is 0.001, so probability is given here, P, given P is equal to 0.001. See, very small. 0.001 means it is almost equal to 0, very small. So this indicates we have to apply Poisson probability distribution. N is equal to 2000, means very large. So we use Poisson distribution. If you know N and P, we can find M equals to N into P. 0.001 into 2000. You will get here 2. So write probability distribution of Poisson, m power x e power minus m by x factorial. M is 2, 2 power x e power minus 2 by x factorial. Here we have to determine the chance that out of 2000 individuals, more than 2 will get a bad reaction. So what is the chance that more than 2 will get a bad reaction after stimulating some injection? So here P of x greater than 2 should take, according to the question. More than 2, right? More than 2 means greater than 2. Don't include 2 here. So we can rewrite it as 1 minus P of x less than or equal to 2. Less than or equal to 2 means we have 3 numbers before to 2. X is equal to 0, x is equal to 1, and also x is equal to 2, because 2 is included. In the formula, we have to put 0 and then 1 and then 2. So simplifying this, you get 0.3233. Directly type all the numbers in calculator. At one shot, we get the answer. So this is another kind of problem. Next, fourth question. In a certain factory turning out razor blades, there is a small probability of 1 by 500. Very small. 1 by 500 means it's very small probability for any blade to be defective. So just read the question and one by one we have to write the data. Given probability is 1 by 500. The blades are supplied in packets of 10. Use Poisson distribution to calculate the number of packets containing no defective, 1 defective, 2 defective in a consignment of 10,000 packets. Okay, here n is given what? 10 packets of 10. Okay, n equals to 10. Use Poisson distribution. First we have to find m here. M means n into p. N is 1 by 10. Sorry, n is 10 here. 10 into 1 by 500. We get here 1 by 50. Correct? 1 by 50 is your m. 1 by 50 means you can write 0.02. You can write this. Now write the Poisson distribution function. P of x is equal to x equals to m power x e power minus m by x factorial. M is here 0.02 whole power x e power minus 0.02 divided by x factorial. This is for single packet. Probability that a blade will be defective in packet of 10. Now we have to find here out of 10,000 packets. Out of 10,000 packets, we have probability of, what's the first question here? No defective. No defective we have to write here. No defective equals to P of x is equal to 0, right? No defective means. So in the above formula, you have to put x is equal to 0 and multiply by 10,000 because we are calculating out of 10,000. So 10,000 into 0.02 whole power 0 e power minus 0.02 divided by 0 factorial. This will be approximately equal to 9802. I think you have understood this. Here the formula is created for only one packet which contains 10 blades. Now the question is asked here, use Poisson distribution to calculate approximate number of packets containing no defective. Okay, so here we get 9802 packets which has no defective blades. Out of 10,000, there are 9,802 packets that has no defective blades at all. That's the meaning. Second question is 2 defective blades. Oh yeah, one defective and then 2 defectives in a consignment of 10,000. Next, this was the first question. Second is probability of one defective. One defective means we have to put x is equal to 1, but we have to multiply by 10,000 to the above probability. So we get yes. Okay. 10,000 into just we have to put x is equal to 1 e power minus 0.02 divided by 1 factorial. So calculate and then multiply by 10,000. It is approximately equal to 196. Third question is probability of 2 defective. Exactly 2 defective. So I have to put x is equal to 2. 10,000 into 0.02 whole square e power minus 0.02 by 2 factorial. It is approximately equal to 2 packets. So only 2 packets we have which contains 2 defective blades. So you can find probabilities first for all these 3. At the end you can multiply by 10,000. To save time here, in the beginning itself I have multiplied by 10,000. So that's the meaning of this question, and we got solution for no defective, 1 defective, 2 defective blades, approximate number of packets. This is one type of question. Next, here, fifth question. A car hire firm has two cars, which it hire out day by day. The number of demand for a car on each is distributed as a Poisson distribution. They clearly mentioned Poisson, so we have to use Poisson distribution function itself with the mean 1.5. So mean is given directly here. M is given directly 1.5. Calculate the proportion of days on which there is no demand, on which demand is refused. So no demand means what? X is equal to 0. Here X denotes the number of demands. No demand means here what? X is equal to 0. Next question is on which demand is refused. So when can you refuse the demand? When the demand has crossed two cars. We have only two cars. Demand is refused when the demand requirement is more than two cars than the available. So first, given m is equal to 1.5, so mean is given, we got it. So by Poisson distribution, we have p of x is equal to x, m power x, so 1.5 power x, e power minus m means 1.5 divided by x factorial. So first we have to find here probability on which there is no demand. So no demand means we have to put x is equal to 0 directly. 1.5 power 0 e power minus 1.5 by 0 factorial. The answer is 0.2231. Second question, probability on which demand is refused. If demand has to be refused means it has to cross the number of cars available. Okay, here we have only two cars. Demand is refused when the random variable crosses 2. Okay, not equal to 2. Equal to 2 means it can be accepted, demand can be accepted. If it crosses 2, then only demand is refused. We have only two cars. If requirement is more than 2 means we cannot provide. So demand is what? Refused. Therefore, we can write here 1 minus p of x less than or equal to 2. This is equal to less than or equal to 2 means x is equal to 0, x is equal to 1, and then x is equal to 2. Substitute 1 by 1 into the formula starting from 0 and then 1. 1.5 power 1 e power minus 1.5 by 1 factorial plus 1.5 square e power minus 1.5 divided by 2 factorial. The answer is 0.1912. So this is the answer for this question. You have to verify all the answers with your calculator. Next question. Sixth one. The probability that a newsreader commits no mistake in reading the news is 1 by e cube. Find the probability that on a particular news broadcast, he commits only 2 mistakes, more than 3 mistakes, at most 3 mistakes. First, let us denote x as committing mistake. Okay. Committing the mistake. Here, to apply Poisson distribution, they are not given m. M is not given. So Poisson distribution function is given by m power x e power minus m by x factorial. And here x takes the values 0, 1, 2, 3, etc. Given probability of no mistake is given here, that is 1 by e cube, right? 1 by e cube. 1 by e cube means here we can write e power minus 3. What's the meaning of no mistake? No mistake means you have to write x is equal to 0, right? According to the data given here, commits no mistake. No mistake means what? X is equal to 0. P of x is equal to 0. Now substitute P of x is equal to 0 in this formula. We get m power 0 e power minus m by 0 factorial equals to e power minus 3. M power 0 is 1, 0 factorial is 1, so we get e power minus m is equal to e power minus 3. Both the sides bases are equal, powers must be equated. So we get here m is equal to 3. In the problem, mean is not given directly, but they're given the probability of committing no mistake. With the help of this data, first we must find m value. After finding m value, we can put it in this formula. Later, we can find the probability he commits only 2 mistakes, more than 3 mistakes, at most 3 mistakes, right? Without m, we cannot find answer for these 3 questions. Therefore, first step is we need to find m value. To find m value, we need to make use of this data. No mistake in reading the news. No mistake means x is equal to 0. With the help of that, we got to know m is 3. Now formula can be created. P of x is equal to m power x 3 power x e power minus 3 divided by x factorial. Just I substituted m value in the formula in the Poisson distribution function. Now the first question is probability of committing 2 mistakes. That's the first question. More than 3 mistakes, at most 3 mistakes. So first we have to find only 2 mistakes. Probability of only 2 mistakes. Only 2 mistakes, x value would be 2. So 3 square e power minus 3 divided by 2 factorial. 0.2240 we get. Second, probability of at least 3 mistakes. That is the second question. At least means you have to take x greater than or equal to 3. We can convert it into 1 minus p of x less than 3. So x less than 3, you have to put 0, 1 and 2. Substitute in the above function x is equal to 0 and then x is equal to 1 and then x is equal to 2. So doing simplification, the answer will be 0.3529. Last question is probability of at most, right? At most 3 mistakes. At most means maximum less than or equal to 3. Including 3. At most means maximum. Maximum means that number is also included. So here p of x is equal to 0, p of x is equal to 1, p of x is equal to 2, p of x is equal to 3. Straight away put all the numbers in the above formula. 3 power 0 e power minus 3 by 0 factorial, 3 power 1 by 1 factorial equals to, we get 0.6472. That's the answer. See, Poisson distribution is very simple because here the distribution function has only one parameter, that is m, mean. Only m we have. So that's all in this video. The problems on Poisson probability distribution. From next video, we are going to start continuous probability distributions. So this is one part. See, in probability distributions, we have two type. First one is discrete. Okay, discrete probability distribution. Next one is continuous. Next is continuous. In this discrete probability, we have two types. One is BPD, binomial probability distribution. Other one is PPD, Poisson probability distribution. So these two we have covered so far. Under continuous, we have again two things. One is exponential, other one is normal. We have covered this portion completely. From next video, we are going to start from continuous probability distributions. Under that, exponential and normal. Thank you.